All right, in learning target 6 and 7, we're dividing, and I wanted to take just a second to explain why we're dividing first with a couple examples here. Factoring 30 and 7,429. Factoring 30, you already did in the room here. You either did 6 and 5 or 3 and 10 or whatever you did. Eventually, when you factored it all the way down, it was 2 times 3 times 5. Agree? And you did that with factoring because you knew the factors. Now take your calculator and factor 7,429. I'm going to save you some headache. What are you doing right now? I see you're punching. What are you punching in the calculator? 7,429 divided by 3 divided by 4. You're just guessing, right? All right, how about this? What if I tell you one of the factors is 17? Does that help? What are you doing with that information? You're taking and dividing it, right? All right, so what did you get? Say it louder. 437. Okay. And it goes further. It does. So you try some more, right? Well, what if I told you one of the other factors is 19? Would that help? Of course. So you divide it, and you get 19 and 23. All right, here's where we're going. In learning target 9, the final target of the unit, you can do the question's just going to say solve it, period. Solve it. Any way you want, solve it. And if you were doing x to the 4th plus 5x squared minus 36, you could factor it using our factoring techniques and solve it. If you're doing one of these two examples over here on the right, forgot to erase something from last period. Say you were doing this one. If you're comfortable with factor by grouping, factor it by grouping. If you're not, this lesson's for you. If you graphed it, it would cross the x-axis at 3. And if it's got an x-intercept of 3, it has a factor of x minus 3. Do you remember that? If 3 is an x-intercept, then x minus 3 is a factor. So what we're going to learn today is how do you take a factor of x minus 3 and divide it into the original polynomial. Take a look at this final down here, this last example. There's no GCF. There's 1, 2, 3, 4. There's 5 terms. I don't have a factoring technique to deal with that. But if you graphed it, you would see it crossing at, I think, x equals 5. So you could divide x minus 5 and start figuring it out. So anyways, that's why we're doing division, to help with factoring, and then sometimes it's the only option. All right, so now let's get to it. Today's division, target 6, is using long division back in elementary school. So we need to fix this issue if it is an issue first. How do you take 3 and divide it into 205 without a calculator? Do you remember these things? Hopefully they taught it. Right. How many times does 3 go into 2? Doesn't. So then you look at the 20. How many times does 3 go into 20? 6. So you put the 6 up here. All right, let me change that question slightly. Instead of how many times does 3 go into 20, what would you multiply by 3? 3 by, I'm sorry, what would you multiply 3 by to get really close to 20, but not go over? 6. So it's just another way of asking the same question. Now what do you do with that 6? Multiply it by 3, put that down here, and then do what? Subtract. Okay, so it sounds like you're remembering this, right? You're subtracting 20 minus 18. Remember, you're subtracting the 2 minus 1 and the 0 minus 8. You just have to borrow from the 0. You have to borrow from that 2 to make it 10. All right, you're subtracting them both is what I'm getting at. But you get 2. And then what do? Right, you bring down the 5, and then you do it again. What would you multiply? I'm changing the question. What would you multiply 3 by to get really close to 25? 8. It's the same question as how many times does 3 go into 25? And the answer was 8. So 8 times 3, 24. Then you subtract and you get 1. And then you had 2 answers, 2 options. 68, remainder 1. You had other options, by the way. Sorry, you had the decimal option. You could have added a decimal 0.0 and kept going. All right, we're not going to do that option. But you could say remainder 1, or you could say 68 and a fraction. Do you remember how to do that? 1/3. Your remainder 1 divided by whatever you were dividing by. So you could write this as 68 1/3. All right, 21 into 485. How many times does 21 go into 4? Doesn't. What about 21 into 48? 2 times. So 2 times 21, you're multiplying the 2 times the 2 and the 2 times the 1 to get 42. I know I'm saying some weird things right now because I'm thinking ahead to our long division in just a second. We're doubling the 21 by doubling the 2 and the 1. Then subtract 48 minus 42, 6. Bring down your 5. 21 goes into 65 3 times. 3 times 2 and 3 times 1, 3 times 21, 63. Subtract, and we get 2. So you have 2 options, 23 and remainder 2, or 23 and 2 over 21. You got it. All right, so hopefully that fixed, if there were any elementary division issues, that fixed it. Now for our notes. I've already kind of talked about what this first paragraph says, so I'm going to very quickly hit on it. Here, number 8 homework problem and number 8 learning target 9. The graph's going to show that x equals 3 is an x-intercept. That's an x-intercept for this problem. Some of you are comfortable factoring by grouping. So you're going to factor that x minus 3 out using factor by grouping. Some of you aren't as comfortable with factor by grouping, and that's fine. Then what you're going to do is divide the x minus 3 out. All right, and one of your 2 methods is long division, the other is synthetic. We're going to look at the long division today. All right, I originally had planned on doing that problem first. I did it in first period. It is not a good first problem. Okay, so I'm going to save it for maybe later. Let's replace it with a homework question, number 11. This is homework question number 11. We're going to take x to the third plus 3x squared minus x plus 2 and divide it by x minus 1. All right, set it up first. Yeah, and I'm with you. I would maybe do this on a separate sheet of paper in here because this is a homework question. It's homework number 11. All right, let's set it up first. Set it up with x minus 1 dividing into x cubed plus 3x squared minus x plus 2. If at any point you get lost in this, it's going to be difficult if you're not stopping me in the middle of what I'm saying to ask the question, okay? It's hard to look backwards. There's so many steps in this process. All right, first question. How many times, and I'm going to ask it the weird way first, then I'm going to rephrase the question. All right, here's the weird way. How many times does x minus 1 go into x cubed? It doesn't. 2 things aren't going to divide nicely into one thing. So there's nothing going to go in the top of our answer right here. All right, moving on, kind of like we did earlier. Moving on. So now I'm looking at x minus 1 and the binomial x cubed plus 3x squared. And I'm asking this question. How many times does x minus 1 go into x cubed plus 3x squared? And I see the look. That's the look I get too. I don't even know how to think like that. So let me rephrase it. This is probably easier to think about. It is easier to think about. What would you multiply x by to get x cubed? All right, that was automatic, right? So our answer, x squared, goes in the top, and those are kind of like place values. So put that answer above the 3x squared. You're building your answer at the top here. And then what did you do? Once you put the number 6 in the top, you multiplied 6 times 3, brought it down, and then subtracted in that earlier problem. So take x squared and multiply it by x minus 1. I'll do that scratch work over here to the side. X squared times x minus 1 is x cubed minus x squared. You distribute the x squared. Put that underneath like you did in those 2 little warm-up problems, and then draw your subtraction bar. Be careful. Make sure you subtract them both. This should always happen. Your first x cubed minus x cubed, they should cancel every time. X cubed minus x cubed. If you did it right, that's going to cancel. All right, be careful on the next one. 3x squared minus a negative x squared. When you subtract a negative, you add a positive, so it becomes 4x squared. Any questions over any of those steps? Because in long division, you bring down the next term, and you do it all over again. You do it again and again until you run out of terms. Right? So let's bring down the next term. Minus x. And now I'm going to ask it the weird way. How many times does x minus 1 go into 4x squared minus x? Weird answer. Weird question, right? It's probably easier to look at it this way. What would you multiply x by to make 4x squared? You would multiply it by 4x. So put that answer above the place value x, if you will. I'm switching colors so you can see. Now I'm multiplying 4x times the x minus 1. Scratch work over here on the side, 4x. You can do this in your head if you want. You don't have to do this scratch work. 4x times x, 4x squared, minus 4x. When you distribute, put that over here and then draw your minus 4x. Draw your subtraction bar. Carefully subtract. 4x squared minus 4x squared cancels. And a negative 1x minus a negative 4x makes a positive 3x. Positive 3x. Last time, bring down the plus 2. You might be able to think like this, but now that it's just x and 3x plus 2, I don't know. How many times does x minus 1 go into 3x plus 2? It goes in 3 times. Maybe not. Maybe you still need to look at it like this. What would you multiply x by to make 3x? 3. So do the 3 times the x minus 1 and subtract. And what do you get? Be careful. You get x's cancel and you get 2 minus a negative 3, you get 5. All right, so you got two possible ways to write the answer. Your answer, of course, is up here. X squared plus 4x plus 3. So you could write it this way. X squared plus 4x plus 3. It doesn't look right. 4x plus 3. With a remainder of 5, I think you could probably just remember that way. I mean, you don't need to practice that. You probably need to practice the other way, which is x squared plus 4x plus 3. If your remainder is 5, I'll remind you, what did you, oops, there we go. What did you do with the remainder 1? And what you were dividing by 3, you made it a fraction 1/3. That is 68 plus. That's what that is, 68 plus 1/3. You just write it as 68 1/3, but it's plus. So your other option would be to write plus your remainder 5 divided by what you divided by, x minus 1. That's long division. In your homework, as far as I'm concerned, you could do both. You could do either. At the end, of course, it's going to ask for both ways. You probably need more practice with the fraction way. What if it had been a negative 5? What if the remainder had been a negative 5? The only difference, that fraction right there would say subtract 5 over x minus 1. That's the only difference. It would have said minus 5 over x minus 1. All right, I'm going to help you get this next one set up, and then I'm going to pause the video and let you guys try a few steps at a time. All right, but we need to talk about something. When we did the first warm-up problem, that 205 had a 0 in it. What's the purpose of the 0 between the 2 and the 5? The purpose is for it to hold the place value of the tens. If I don't put the 0 there, between the 2 and the 5, that's the number 25, and you're dividing into a different number, right? So the 0 acts as a placeholder, There's a similar concept you have to use when you're dividing polynomials, and that's illustrated in this one. If you're dividing an example 2 into the polynomial x to the fourth, the next place value beside that is an x cubed, and it doesn't have one. So you're going to need to hold that place value with a 0x cubed, a 0x cubed. Then next to that should be an x squared, which this has, and then it should have an x. Since this one doesn't have an x, you're going to need to hold that place value with 0x. Now, I also, a little disclaimer, I realize that this problem in particular doesn't necessarily need it, but because there's so many that do, the blanket statement is put your zeros in, hold your place values, and it'll always work. Okay, all right, so let's set it up together. You're going to take x plus 2 and divide it into this polynomial. You're dividing it into x to the fourth plus 0x cubed minus 8x squared. And if you're writing this on your notes, which is where you should put it in your notes, leave enough space so that you can put your answer above that bar. Plus 0x plus 16. All right, now I'm going to pause the video after I give you one small, subtle hint. Your first thought, what do you multiply x by to get x to the fourth? X times x cubed. Put that at the top. Go so far as subtracting your first binomials, but stop there. All right, I'll pause. All right, check your work on the board. Any questions about any of those numbers or any of that process? You okay to there? All right, same thing. Bring down the next term then and try it again. Just go so far as the subtraction step, then check it again. Stop me if you have a question. It's almost impossible to look back. If we do the next step and then look back and say, now why was that -2 again? It's very difficult to do that, okay? So stop me in the middle of the problem if you have a question. All right, so go for it then. I'm looking at the x and the -2x cubed. What would you multiply x by to make -2x cubed? What you might be experiencing right now while you're trying this first question on your own is what happens a lot of times in here. When I'm asking the questions, it's easy to know what to do next. It's easy because I'm asking the questions at the right time, kind of leading you through it. It's much harder when you get home and try to do the homework on your own, and no one's asking you any guiding questions. All right, so try this one question completely like this on your own, Make yourself come up with the question before I ask it. -8x squared minus a -4x squared becomes plus. So -4x squared. Any questions on that -4x squared or any of those? All right, then go ahead and try to finish the whole thing. Finish the entire problem from there. Bring down the 0x. All right, I know I've kind of been quiet while I'm working up here, but you should get a remainder of 0. Now, why is that? Because x plus 2, at the beginning of the problem, it's noted up there. X plus 2 is a factor. If something is a factor, when you divide it, you're going to get no remainder. When something is a factor, okay? So your final answer is just x cubed minus 2x squared minus 4x plus 8. Meaning, this original polynomial factors 2x plus 2 times x to the third minus 2x squared minus 4x plus 8, which would factor further by grouping. This is us talking kind of in terms of what's happening in Learning Target 9. Okay, this is why we're even studying division. We could keep going. Our calculator will help us keep going. But anyways, the answer is just x cubed minus 2x squared minus 4x. Last one, it's much shorter. If you're dividing 2x plus 1 into this quadratic, all of the terms are there, so we don't have to have any place values, if you will. First question, how many times does 2x plus 1 go into 4x squared plus 8x? Weird question. What do you multiply 2x by to get 4x squared? 2x. You can probably do this in your head now, right? What's 2x times 2x plus 1? 4x squared, and then 2x times the 1 plus 2x, and then subtract. Cancels. So what would you multiply 2x by to get 6x? 3. So plus 3 goes in the ones, if you will, the first place value. 3 times 2x plus 1. 3 times 2x plus 1. 6x plus 3. And what's your remainder? Remainder is 2. Okay, so you could write it one of two. Your answer is either 2x plus 3 remainder 2, or 2x plus 3 plus 2 over 2x plus 1, the thing you divided by. All right, and then evidently show them how to set up 16. Evidently there's something going on with 16. Let's see, 16 says x cubed minus 13x squared. Oh, minus 13x minus 12 divided by x minus 4. All right, so I can see why it says show them how to set it up. X minus 4 is being divided. Well, it's going to go under that division bar. If x cubed is your degree 3, what needs to be right after that? And x squared. So make sure you put a placeholder there, x squared, then the minus 13x, and the minus 12. Then you're good to go. Any questions? All right, Tuesday, we'll do synthetic division. Long division is kind of like completing the square, and synthetic division is kind of like the quadratic formula. You're going to end up liking synthetic better and use it more often. But there is a place for long division. We'll talk about it on Tuesday, but it's for this problem we just did. If you had to do this problem with synthetic, you'd have to do a lot of fraction work, and it's just not something I think some of you are going to want to do. So that's the main place we use long division. Okay, all right.